Hello, thanks very much for coming. We have quite a lot of stuff to get through, so the slides will flash by rather quickly, especially the part about what we do. I'm Lucas Oberhuber. I'm Chief Technology Officer at Simply Business, and this is...
I'm Daniel Barlow. I'm the lead developer on this project.
Next slide. So we have about 400,000 policyholders. We're the UK's biggest online insurance provider in the business space. So we insure primarily people like architects and plumbers and so on. We have about 49 million in revenues and 350 employees. And this is an example of the back office, the Twilio UI we've built in our, go ahead and let her rip. And it's actually being tested automatically, so you can't barely see that, but we're testing our dialer that we've built in Twilio. And there you got to see it. The user's logging in. This is all happening automatically, by the way. And there it's in ready state. Phone call goes out to Mr. Smith. RFQ is our lead, so that's what a lead is. It's dialing. Oh, Mr. Smith has answered.
Anything you still can't cope.
And now we're connecting to a service team that will help us close this call. And now we've said goodbye, we're wrapped up, and we've gone home. All right, that's it. So that's our test running our UI. Next slide. Next slide, that's what you just saw. So why did we choose Twilio? There's a few different reasons, probably the same reasons most of you chose Twilio. It's data-driven, flexibility. Testable was really important to us, so that's why we've built these automated tests. We want to be able to continuously deliver, continuously deploy, integrate, et cetera. The programming workflow, so we could decide how things would work. We could build it based on our use case and then iterate on it, where a lot of the off-the-shelf solutions are quite restrictive, and it's extensible. Next. So why do we test on a continuous integration platform? First of all, some of the rules we've put in place, or I've put in place, or whatever, our automated testing is a must. We must have zero downtime deploys, meaning that during the day, while our consultants are on the phone with customers, we can deploy this application, and we need to be sure the integration is working in order to do that. So if we were to deploy and not know it's working, that's not a good idea. Next. So what will you learn in this session is CI, continuous integration with Twilio, is easy. However, there were some challenges that we overcame, so you don't have to. You will learn how to do it, and we will show you the code. And we've open sourced the code, although we need to put a license in so that you can even steal our code. So what are some of the challenges? Well, the presentation, I'll go through the challenges we faced. Prerequisites, what you need to do this. We'll show you on a local application. We'll show you an automated test on the local application running on this very laptop. And then we'll show you it running on Semaphore CI, which is a continuous integration server in the cloud, service in the cloud. And you can choose your own if you don't want to use theirs. So some of the challenges we faced. First one was detecting the state of the Twilio device on the client side for our tests to be able to know where we stand in the tests. The second was automating an incoming call, because otherwise someone needs to sit there with a phone, which is the first demo we'll do. Third is automating the public IP for our Twilio application so that the Twilio callbacks will come into the application so it works on the CI server. And finally, putting WebRTC on a headless browser in the cloud somewhere, which is kind of important if you're making a voice call. So the prerequisites, Chrome driver, you'll need that to be able to drive the tests. EndRock allows you to get through the firewall. Ruby is what our programming language is. Bundler is how you put it all together. Semaphore CI I talked about. Twilio you've never heard of. And XVFB is the headless browser driver, so that allows you to have screens where things happen. And so let's do it. And Dan, you're going to take over from here, so I'm just going to hide in the corner.
So I'm going to start with a demonstration, and we're going to fire up the server. So what we did was we took one of the demonstration applications from the Twilio website, showing Twilio client and how it's handling with an incoming call. So we've started our server there. We're going to go to localhost. There are two bits to this, the Twilio client WebRTC's system and some routing to actually fire incoming PSTN numbers into it. So Lucas is now going to make a call into our soft phone.
It's demo before. Hello?
Hello?
Have you seen?
Have you seen this demo before? Someone making a phone call in a Twilio demo? You have? Okay. Thanks. Bye.
So that's what it did. And let's just have a quick look at how it did it. So we've got several bits going on here. We've got the browser soft phone client itself, which you just saw. We've got the server-side application running behind it, which was the sort of texty, geeky, webby, codey stuff, which everyone's actually here for, yeah. The browser soft phone is WebRTC. It talks into Twilio. Twilio also accepts connections from the public service telephone network and routes them to our soft phone. And the other bit which is in there is the little cloud for EndRock, because we in here are obviously not on the public internet. We can't accept incoming connections. So that is the proxy service we're using, because the Twilio REST API, if you know it, depends very heavily on being able to make callbacks into your own application. So as I say, the back end here is serving the browser soft phone web page, and it's also responding to the webhooks for the Twilio incoming calls. So let's look at some code. Woohoo. And we're going to start with the page which displays the soft phone. And this is pretty much boilerplate stuff, to be honest with you. It issues some SIDs and so on. It configures the soft phone client with the username Jenny, and we'll see why that's important in a moment. So that's half the battle, is getting the soft phone on the screen. The other half is how we get numbers, inbound numbers into the soft phone. We have a Twilio number configured, which is the number Lucas called a moment ago. And that is configured in Twilio such that when a call comes in, it invokes a webhook, which is the which is our /voice endpoint behind our EndRock tunnel. And there is the voice endpoint. So what it's saying to do when somebody calls that number is dial the Twilio client application, whose name is Jenny. So net effect, the number comes from the PSTN into Twilio. Twilio asks us what to do with it. We say to connect the soft phone. Lucas is now talking to my Macintosh. OK, so the next question is, how do we test it? Let's go back to the application for a moment, because there is just one more thing I want to show you there, which is if we are going to do some geeky codey things, if I reload that, you will see that once it's finished loading the page, there's a fair amount of asynchronous stuff going on where it's connecting to the Twilio WebRTC stuff. And I'll come back in a moment to why that's important. So, at Simply Business, we test our applications using the Gherkin BDD language, which is what Cucumber is based on, which is familiar probably to a lot of Ruby developers. There are Ruby developers here. If you're not familiar with it, each of these lines is more or less plain English text, but it corresponds to a piece of code which goes on behind it. So here's the first step, and here's the first challenge we have to face that Lucas is talking about. A consultant is ready to receive a call. We do that by bringing up the client, visiting the root URL, and then we have to wait for all that asynchronous stuff to go on. So that's what have device Twilio device status is doing. And if we look at how that's defined, we can see it's actually running a little bit of JavaScript on the web page. It's talking to the Twilio client's JavaScript directly to find out what the status is. It tries that 10 times. Hopefully it succeeds in less than 10 times.
I think we're missing a little bit of the code on the right there. Yeah, so you can see.
Yeah, OK. So that's testing. It's got the expected status, which in this case is going to be ready. So that was the first challenge. How do we find out if the device is ready? We use JavaScript. We use the Capybara JavaScript evaluate script command to find out if the device is ready by interrogating the Twilio device. Second step, when a customer calls, we don't have an infinite supply of fake customers manning mobile phones to test every time we make a change. Obviously, that would be silly. We do have a programmatic voice platform, which is quite good at placing phone calls over the internet. It's called Twilio. So we're going to use Twilio to do that step. So here is the step a customer calls. It's invoking that method, which does this. This is the Twilio-based API. It says when this method is invoked, we're going to call the number which Lucas was calling a minute ago. That's what that to number is. And when the call is answered, and remember the call is being answered by my Twilio client softphone, it's going to retrieve some instructions at that URL, which is customer voice, which is this message here. So let's see how it works, whether it works. Does it work? I'm going to terminate that so it doesn't interfere. I'm going to terminate that so it doesn't interfere. And we are going to run our automated test. Look, no hands.
Signal Conference London. Lucas is a fine young lad. Buy him a pint after this workshop.
If everyone in the room does that, he's not going to be in work tomorrow, is he?
Some of them should go to Daniel.
So that was the second challenge, is how do we actually test a system which is expecting an incoming customer? As the answer is we use an automatic call.
And you can see the test passed.
You can see the test passed. Everything is green, yeah. So what's the next bit? We talked a little bit earlier about EndRock, our proxy service for getting us on the internet. Now, when we put this test into a cloud-based CI server, technically they're on the internet, but practically speaking, they're going to be firewalled off. They're not going to allow you to run incoming services in their CI environment. So we continue to use EndRock in the CI service as well. Now, that means we need to know what our public URL is. And we need to tell Twilio what our public URL is, because the chances are, especially with EndRock, that's going to change every single time we run the script. So this is a little bit of code that runs when the application starts up. And it calls EndRock runner, which fires off the tunnel automatically. There it is, starting EndRock. And then it's going to interrogate the EndRock API, which runs on localhost, and will give you details back in JSON format of the tunnels you've got running. And then it's going to use that URL to set up the incoming numbers in Twilio. So if you remember the Twilio page you saw earlier with the EndRock thing in it, every time we run that test, that's going to update automatically. We don't have to keep going back to it.
So you can imagine if you're running these in parallel and you have a number of different EndRock URLs, you might need to figure out individual phone numbers for each one of your test runs.
So that's 3 out of 4 we've covered. We've covered the testing the browser is ready to receive calls. We've tested placing the call. We've tested making us available on the internet for a thing. What we're going to do at this point is we're actually going to show the thing running in a cloud-based CI environment. We use Semaphore for that purpose. There are others available, but this is the one we use. Here is our application set up in Semaphore. You'll see some previous builds in the system. And we're going to start by firing off a test on the master branch. I'll do the demo first, rebuild last revision, and off it goes. The setup of that test, here it is. Here is our application. Every time we trigger a build or push some code, it's going to be running this script/CI script. Here it is. It's doing more or less what we did interactively a moment ago. A bundle install, an npm install, and a bundle exec rake being the actual test run itself. And if we check back, it may even have finished. No, it's still building. OK. Now, there is one thing I haven't talked about, which you could claim is the pivotal thing for the whole application, which is how do we actually test a interactive voice application, well, interactive bit we've covered, how do we test a voice application which uses the microphone and uses the speakers on a computer that doesn't have a microphone and doesn't have speakers? And the answer is, of course, you fake it. Our test setup using Capybara is using a custom driver. It's using Selenium. Selenium is driving Chrome driver, or possibly the other way around. But we have some special flags on the Chrome application to say use fake UI for media stream and use fake device for media stream. Now, if you're headless, you need those absolutely because you don't have a real device for media stream or a real UI. If you're not headless, it still helps because otherwise you get a pop-up saying allow Twilio to use the microphone, which sort of interferes with your hands-free testing. So that's the fourth and final part of the puzzle. So if we go back to our original challenges and recap what they were, what you need to be able to do, you need to be able to detect the Twilio client. You can do that using JavaScript and Capybara. You need to be able to automate the incoming call. You can use that using Twilio, of all things. You need to be able to tell Twilio where your public IP address is, even when you're not on the public internet. We use the EndRock introspection URLs for that. And you need to be able to run WebRTC on computers that don't have microphones and speakers, or computers that don't even exist because they're virtual machines in the cloud. And that pretty much wraps it up for me. All that remains is to give you the URL where you can see the fruits of our labors.
So this is an open source application that we made that allows you to test out, and please put your own credentials in there. We didn't put ours, but you should be able to automatically test and go from there. So it gives you all the tools you need to do this. You've learned how easy it is. I know we breezed through the code actually faster than we ever expected. We've never gotten through this. The last time we did this, it took 45 minutes, and we're running ahead of time, Dan. What happened? You didn't rest on the code segments quite long enough. But yeah, to us, this was extremely important. It didn't seem like a lot of other people were doing this, and it didn't seem like it was, we thought it was a huge challenge, but then when we went ahead and tried to do it, it worked. So hopefully you can do it as well. And I think we have time for questions, ridiculously. I don't know, maybe you can run around with the mic if anyone has any, or we can just, end it here.
We have 5 minutes, so if you do have a question, throw a hand up.
Stunned, shocked.
Should we do it all again? I mean, there's time.
So what's in the future? What is the next step?
For us?
Yeah.
So this is just a small component of what we're doing. So we've built an outbound dialer for our business. We're going to build the inbound phone system that we're also going to continuously deploy. So IVR. We're then going to add things like SMS, et cetera, potentially emails. So we right now we're looking at a primarily phone-based contact center. The next step for us is to add those other things. But we're in the first. We basically rolled our contact center out to half of the first team. And what's interesting is we're starting to see the need for doing tests to see what's happening, what do consultants do, how are they contacting the customers, what do customers actually want from us. So we've got a platform in place to allow us to start to test, and that will drive a lot of the direction going forward. And the goal is, one, to have a more stable platform. Yesterday we had a full-day outage of our legacy phone system, which was very unpleasant and reminded us why we started on this journey. And yeah, so rolling that out to the entire contact center of 200 people is quite important. And then starting to build in additional features that are more customer focused. Anyone else?
Oh, right at the back. It make me run.
You need the exercise, right?
If the next question comes from over here and then the next one from over there, we'll just get sort of the most pessimal microphone routing possible.
Do you have any practical advice for making these tests reliable? Maybe they've been perfect for you. In my experience with Selenium and driving the web browser, it's been been a little bit painful now and again. So I don't know if you've got any practical advice there.
Oh, yes. Tons of it.
It has been exciting, yes.
I think the first thing I'd start with is ban it's just the internet, Selenium driver's unreliable, Chrome driver's unreliable, it's someone else's fault, you just can't possibly test Ajax correctly, blah, blah, blah. To be honest, none of those tend to be the real issue. Occasionally true, but a lot of what happens is the code wasn't built with asynchronicity in mind, the code didn't manage timeouts, didn't understand that occasionally things take a bit longer to happen or an event will come out of order. All of those things, which actually apply to our website as well. So we have a long history of flaky tests that we've had to spend the time to figure out what's gone wrong. And one of the maybe this is very familiar to all of you, but there's a real habit of saying, well, it worked for me, the test failed once, I just reran the test, it was fine, and moving on. And that's why your tests are flaky. You didn't spend the time, you didn't focus on making it reliable. So we are still in a bit of that challenge with this, but with our main web application, we had exactly the same thing. And the simplest thing is to put in a rule, which is if your tests fail, then the whole team needs to stop work until they start working again. And there needs to be a commit into the repo about fixing that test before anything else can go live. And that's it. You have to be extraordinarily disciplined. And if things are flaky and they don't matter for the purposes of your test passing, then you should ignore them being flaky. And if they're absolutely critical to your test passing, you need to figure out why your application is flaky or why your tests are flaky. So
it is, sorry, I was going to say it is unavoidably hard because it is multi-threaded code. Basically, I think the answer is you knuckle down and do it.
Actually, if you pull up the piece of code, that piece of code there was a source of flakiness.
That was an example we actually hit in the process of looking at this, which is, where was it? It was right near the beginning, wasn't it?
You're getting there.
Getting there. One of these.
Next one.
Yes. Yeah.
So this piece of code, you've got the capybara default max wait time. So before, this was just a piece of code that waited for whatever number of seconds, and then it returned, and it didn't fail if it didn't succeed. So we would get 4 or 5 steps down the application testing, and then have a failure, and people are like, oh, this is flaky, but we hadn't waited long enough on here. Simple as that, right? Sometimes it takes a bit longer. I don't know if that answers your question. Any others? Yep, there's one over there. We're not out of time yet, are we?
Last question. I've got a minute left.
Hi there, I'm Mike. A couple of questions, really. The first one is just being nosy around stats in terms of volumes of calls that you've had through the system and number of agents. And secondly, how have your agents found the difference between using a physical hard phone and WebRTC?
Excuse me. So stats-wise, I don't know the total number of calls. We have 4 to 6 agents using the system actively right now. So we haven't scaled it up yet. That's half of one of our teams. And we're looking in the next few weeks to roll that out to all the agents. And the main reason we haven't is functionality we haven't built yet, so it doesn't fully support their workflow, or at least that's the impression we're getting. So we're testing that out. How have consultants experienced it? I think very well. They say the call quality is really clear. The big question, we had some, I think it was, we're using Chromebooks, so the analog audio headsets had some crackling and issues like that in them, so we switched to USB headsets. We're trialing some Bluetooth headsets, which seem to be quite appreciated. Consultants sometimes don't like the cones on both the microphones on both the speakers on both their ears, things like that. So it's really about finding the right headsets. We've got analog headsets that also work with splitters. So how do you listen to calls in real time with those headsets? That's not very easy either. So there's definitely a bunch of things. You're basically probably replacing the entire desktop for that agent. But yeah, we found phones that work well, and certainly feel free to email us. We haven't fully decided what headsets we'll use, but we're happy to give you advice on what products have worked for us. Does that answer all those? I think there were 3 or 4 questions in there. Okay, okay, we're done. Thank you.
Thank you very much.